Example 1, part 4. We want to find cos of minus 3 pi over 4. Okay, so we're going to do, let's draw 3 pi over 4, or minus 3 pi over 4, on my diagram. So, minus 3 pi over 4, that means I'm going to go anti-clockwise, clockwise. So, normally if it's positive angle, we'll go this way around. Negative angle, we're going to go this way around. So, a quarter, so that's half pi. That's a full pi. So minus 3/4 pi will be here. Actually, exactly in the middle. So that's your 3 over 4 pi. Okay, so we want to find cos. So we want the x value. So we want that. Well, what can we do? Well, if that's 3/4 pi, that's a quarter pi. Or we can instead let's write pi over 4 just to save a little bit of space. And what can we do? Well, we want to find things in here because those are the values we know. So what we're going to go to a quarter. So pi over 4 here, and say, well, and then find the x value for that. So find cos theta for that. And this is on this side, so this is just the negative of that. So this is equal to minus cos of pi over 4. Now, cos of pi over 4 is, I think, root 2 over 2. We can just double check on this. Cos of pi over 4 is 1 over root 2 or root 2 over 2. Same thing. So the answer is minus root 2 over 2. You may have seen, or you may have been tempted to do it this way, a slightly longer way of doing it if you didn't draw the diagram. So you could have gone, so that's exactly the same as cos of 3 pi over 4, because when you have a cos minus there, I can take the minus doesn't really matter because we say cos of 3 pi over 4 minus 3 pi over 4. It's exactly the same as if I went this way around and cos 3 pi over 4, giving the same x value. But it still doesn't give us the one we want, because the one we want is this. And then that's equal to this. That's equal to that. There's no point doing it this way around. Okay, so let's move on. Now we want to find general solutions. Again, we're going to use the circle. So actually, let's just copy this so we don't have to draw it again. Again, we're going to use this instead of drawing. So in class, I used in class we did the cos and sine graph. So now I'm not going to do that anymore. Although you still can do that method. So if you want to use that method, you still can. So we want to find the general solution of cos theta equals minus 0.7, and we're doing it in degrees. So cos theta, again, we are allowed to use a calculator, by the way, it's minus 0.7. Now what does that mean in our diagram? Well, we're going to find an angle that gives us minus 0.7. So if that's minus, remember, cos theta is equal to x. So we want to find an angle. Now there are two possible answers to that actually, so that we get minus 0.7. So we're going to find this angle. So let's draw this. I'm not especially good at drawing straight lines. So there. And we can also go down. So now looking at this, what you can see, to get minus 0.7, remember cos theta is equal to your x. So this is my x. So I've got minus 0.7. I want to find the angle that gives me this. So I've got this angle here, and I've also got this angle here. But just by looking at symmetry, you can say, well, these angles are the same. This is just a negative of that angle. So all we need to find is that angle. So we're going to use our calculator. So for this, you're going to use we've got this up. So we're going to do inverse cos. So theta is equal to inverse cos 0.7. And so theta is equal to, let's get the calculator up again. So it's in degrees, so check that. 0.7, minus 0.7. That gives me an angle 134, and that makes sense. If you think about angle 134, that does work. So theta is equal to 100. There's three significant figures. Let's just check it's 134 and not 130. It's 134. So 134 degrees. And actually you can rub. So that's what my theta is. So what's my other possible answer? That's not my only possible answer though, because I've got this one. So if that's 134 degrees, well, this one is minus 134 degrees. And cos actually works this way. When you're finding your two solutions, cos is just the positive and the negative. Now, these are two solutions. The general solution is all possible solutions. Now, let's just think about this one. Forget the minus 134. Let's just think about 134. That's not the only possible angle that will give me this. I can add 360 degrees, and that'll also give me minus 0.7, and then go on another 360 degrees. Just think about it. Every time you add a 360 degrees, you come back to the same point. So it's actually 134 degrees plus 360 degrees. But now I want to say any amount of 360 degrees. Actually, ignore the degree. You don't need to write the degrees for these bits. It's assumed. If you just say, so theta, so it's not actually equal to this. This is just these are just two answers. I want all the possible answers. So 134 plus 360, but not just one lot of 360, any amount of 360 degrees. So I say 360 n. And similarly, you're going to do the same thing for this one. So I've got minus 134, any amount of 360 degrees, so you can go this way around. It doesn't matter if you go, so you can go positive, so that's one lot of 360, it's another lot, and so on. Or you can go the other way around, it doesn't matter. You can say minus 360, minus 360. Still gives me this, still gives me minus 0.7. So it's also equal to, or theta is equal to minus 134 plus 360n. Notice I don't need to do plus or minus 360n because n can be positive or negative. It's just whole numbers where n is any integer. That's it. Let's go to example 3. Now we're going to do this with sine. Again, we're going to still use this circle. Remembering 1, 1, minus 1, minus 1. Okay, we're going to solving in degrees. The general solution of sine theta equals minus 0.4. So what is minus 0.4? Remember, sine theta is your y. Remember, so is cos theta equals x, sine theta equals y. So we want minus 0.4, and that's over here. In fact, let's do it a little bit so it's a little bit more accurate. So minus 0.4 will be there. And I'll do this. I think red will be a little bit more visible. So that's minus 0.4. So what do we want? Well, we want the go to the circle. Again, whenever we do these, we're using and we want, because it's we want the sine theta is the y, so that's why we're doing the horizontal line. And we want the two angles which give me these two. So the two angles. So I want, let's actually do this in blue so it looks a little bit different. So I want, so these two angles, and I'll point out which angles I mean, will give me, and when I do sine theta of this angle, or, now you can go all the way around this way, or you can go around this way, it doesn't matter. Let's just, for now, let's just say, just go around this way around. This angle, and this angle, whatever these two angles are, so sine of this angle, well, is the y. Remember, sine of an angle is y. So sine of whatever this angle is will give me minus 0.4. And sine of whatever this angle is will also give me minus 0.4. So how do I find that? Well, just use your calculator. So what we're going to do is theta equals inverse sine 0.4. By the way, this will only give you one of the, if you do your calculator, this will only give you one of your answers. We need to find the other one. Again, you can do this using your curves, but I think it's easier now to use this circle. So inverse sine of minus 0.4. That is in degrees. Okay, so it's minus 23.57. And let's actually, for AQA we do it 3 significance, so let's just say it's minus 23.6. Okay, so which one is that? Well, clearly it's that one. That's minus 23.6. Well, how do I find what this one is then? This big one. Well, that one must be, or it's either minus 23.6 or this one. Well, that's just, if that's 23.6, that's 23.6. We're just using symmetry. It's 180 plus 23.6, so it's 203.6. So I've got my two answers. Now I just need to think about, well, those aren't my only answers. From this one, I can add any amount of 360 degrees and it'll still give me this minus 0.4. Same thing for this one. Like before, any amount of 360 degrees going, doesn't matter if you go around this way or if you go that way, any amount of 360 will still give you this same angle and still give you minus 0.4. So my final answers are just theta. So each of these, really, I just said plus 360n plus 360n. As easy as that. Notice I think you started to get the picture. Doing this with a circle is much easier than doing it with the sine cos curves. Okay, example number 4. I think now we're going to do one with tan. So tan is a little bit trickier with this. Okay, notice. So let's get our that. Now, when you're drawing these, what we're drawing here, what we want to keep is it's a unit circle of radius 1. That's all. As long as you just remember that it goes from 1, 1, minus 1, 1. That's all you need to know. Okay, so example 4. Again, these are, and if you want to see an alternate way of doing these, if you go to integral, they do have the solutions to these as well. So we're finding the general solution of tan theta equals 1. So we're getting 1. So how do we, this one's a little bit trickier. So remember, so for this, I won't bother actually using the circle. I'll say theta is equal to inverse tan of 1. You do that on a calculator, and again, we're doing it in radians, so this will give you pi over 4. And when you're doing tan, all you need to really remember, so that means pi over 4 over here will give me 1. And that doesn't make sense, because when I get pi over 4, remember tan is sine over cos. Whatever I get here will be exactly the same as what I get here, so this divided by this must be 1. Because 45 degrees is exactly halfway between 0 and 90. At 0, I've got 1 for cos, 0 for sine. At 90, I've got 0 for cos, 1 for sine. Halfway in between, at 45 degrees, they're both equal, so sine over cos must be 1. So it's pi over 4. This angle is pi over 4. What's my other possible angle? Well, as I said, if you remember earlier, what I said was tan takes the same values, but here and here they'll be negative, here and here will be positive. So the other place where I can get positive 1 is over here. So what angle is that? Well, that's simply pi over 4 plus 180 degrees, or plus pi. So actually, let's do that as a simple separate answer. So that's pi over 4 plus, I'm going to write it for now as pi over 4 plus pi. And let's do our general solution. Now, if you do the tan graph, now I'm not going to do, it's harder to see with the circle, but the tan graph, if you remember, the tan graph repeats every 180 degrees or every pi. So to get the same answer, you just do plus n pi. Now, looking at this, I've already got the answer. So you could do plus n pi here, but you'd already see, notice this is in here. This is just pi over 4, and if you make n equals 1, pi over 4 plus pi is what this answer is. So there's actually only one answer. So when you're doing tan, you can do it directly from the calculator. When you're doing inverse tan, you just get one answer, and then you're going to do plus n pi, and that's it. And it's pi equal for tan, and if you're doing it in degrees, it's 180 you add, because tan, and this one is actually, this is the only one where I think the diagram helps quite a bit. Tan repeats, the difference between that and that is 180 degrees. And you only need one answer. Notice for any time, we just find one answer, and then all the other ones are its repeats. Okay. Example 5. So we're getting to the harder ones now. We're going to find the general solution in degrees of the equation 2 cos 2 theta plus 1 equals 0. So to do things like this, you do need to rearrange it. And your rearranging is essentially like you would do business. So we're going to make cos 2 theta the subject. So we've got 2, and that's actually paste. We're going to use this again. We didn't use it last time. This time we will use it. So we've got 2 cos 2 theta plus 1 equals 0. We're going to make cos 2 theta the subject. So cos 2 theta equals minus 1. Sorry, that should be a 0 there. So it's minus 1 divided by 2. Now ignore the 2 theta. Imagine that was just an object. So we're just going to solve cos of x equals, no, let's not use x because we've used x before. Cos of phi, let's say, not theta, is equal to minus half. So we want to find what this is. Well, what do we do? So phi, or rather, if you don't want to use a different variable, you can just still say cos. We can just use this and work out cos of, and work out the 2 theta. So 2 theta is equal to inverse cos of minus a half. Well, let's actually go to our triangle. Again, imagine the 2 theta was just a theta, and we're just treating this as one object. We don't care about the 2 right now. So we've got minus a half. Remember, cos of theta. So all you really need to remember is cos theta well, there are quite a few things you need to remember actually. Cos theta equals x, sine theta equals y. So cos theta equals x, so it's equal to minus half, so it's a minus a half in your x. So there, because x is 1 minus 1 there, so it's minus a half there. So this time, so when you're doing cos, you draw vertical lines. So you might think, we want to find the angle which gives me that x. When I did sine, I wanted to find the angle which gave me that y, so I did a horizontal line. So we're looking for and you should already be able to see it from the diagram. We're looking for this angle. And just by symmetry, this angle is exactly the same as this angle, will be exactly the same as that angle, but the negative of the angle. You could, if you want to, go all the way around and say, okay, we've got that angle and this angle. But it's easier to just say, it's this angle and the negative of that angle. So what is that? So we just use our, the calculator. So inverse cos of minus a half. Or if you don't want to do inverse of cos of half, you could actually say, okay, instead of doing that, I can go to half. And if I do, so we can use the method we did before. So I go to half. And then that gives me, well, what does that give me? Well, that'll actually be 60 degrees. Yes, 60 degrees. I'm doing it in degrees. So you can use that, you can do that in your calculator as well. So, and just to confirm, well, I know it's right, but just for your peace of mind, so inverse cos of 60, wait, what? Not inverse cos of 60, sorry, inverse cos of minus a half. Well, what did I say? I said this will be 60 degrees. So this will be, this bit is 60, so this is 180 minus 60, so it should be 120. There we go. So again, you didn't need to do what I did there and say go over there, because there's no point. You just use your calculator. So inverse cos of minus a half is 120 degrees. So notice we're just using our calculators here. When we did right at the beginning, we were finding things like this. When we're finding cos of a value, tan of a value. When you're trying to find that, we already knew what the angle was. We're trying to find the value. When we don't know what the angle is, we just use our calculator. So we know this time around, this is the bit we don't know. We do know what this is. We just use our calculator. So give me 120 degrees. That means that's 120. So that must be minus 120. So your 2 theta has two possible values. Is that, or 2 theta is equal to minus 120. So 120 up here, minus 120 up here. Well, what do we say? We said, well, it repeats every 360 degrees, doesn't it? So it's plus 360n. Plus 360n. Okay, so that's what 2 theta is. Well, theta, just simply divided by 2. Divide that whole thing by 2. So it's 60 plus 180n. Or minus 60 plus 180n. So if you want to write your answer in one go, with cos, you'll see if you look at marks for theta, it will be equal to that should be a 60, apologies. So plus or minus 60 plus 180n. Okay, let's move on to something a little bit harder. We want to find the general solution in radians of this equation. Okay, now that looks much trickier. So this one is one that you actually need to use some techniques that are in, I think, C3. So we've got 2 cos theta sine theta plus cos theta is equal to 0. Okay, to solve this, well, we've got something is equal to 0, and looking at this, there is a common factor we can factorize out. So it's always a method you can use, well, you can try using, is if you've got something is equal to 0, and you've got something that factorizes, well, then we can put it into double brackets, or in this case, it won't be double brackets. We can factorize it, and then we know either one of those two things have to be 0, because when we've got two things multiplied together to give you 0, one of those is 0, or the other one is 0. Or they're both 0, but in this case, sometimes they both can't be 0. Okay, so what's in both? Cos theta is in both. So let's factorize out cos theta. And that gives me 2 sine theta plus 1 equals 0. And now all we do is solve each one. So we either cos theta equals 0, or 2 sine theta plus 1 equals 0. Let's do cos theta equals 0. Now, you don't necessarily need your circle, but let's use our circle. It's useful because you should know, this is one you should just really know off the top of your head what values or angles give you cos is equal to 0. But if you don't remember, so I'm getting an x value of 0. There's my x value of 0. Which two angles give me that? Well, 90 degrees, and we're doing it in radians, so it's not 90, it's pi over 2. Or you could say 90 degrees and just convert it. Or this one, which is, well, you can either say it's 270 or 3 pi over 2, or we're just going to go anti-clockwise, or sorry, clockwise, and I'll say it's minus pi over 2. So what does this give me? So it gives me theta is equal to, and I'm going to write it in one go. It's either pi over 2 or minus pi over 2. So let's just say plus or minus pi over 2. You can do this with cos. You can't do it with sine, because sine you get different values. And as I said before, cos repeats every 360 degrees, and you can get that from the graph as well if you wanted to. Cos repeats every 360 degrees, so it's plus 360. And or in this case, it's in radians, so it's plus 2. And remember, 360 degrees is 2 pi, so it's 2 pi n. Or usually I would actually prefer writing 2n pi. It's just a preference. So theta is equal to plus or minus pi over 2 plus 2n pi. In fact, let me just check. I think I may have made that mistake earlier when we were doing it into radians last time. No, last time we did it in radians, I also used pi, n pi. This one was tan, so it is n pi. But if you're doing sine or cos, it's 2n pi, because sine and cos repeats every 360 degrees or every multiple of 2 pi. So this is a multiple of 2 pi. Okay, let's solve this one. Well, to solve this one, this rearranges to sine theta equals minus a half. So take the 1 over, divided by 2. So let's look at our diagram. What does that mean? Well, sine theta is equal to minus a half. Remember, sine is your y. Again, all sine theta is equal to y. Cos theta is equal to your x in my unit circle. So I've got minus a half in my y. So I've got there minus a half. So I'm looking for my. So what do I want? Well, clearly I want these angles. I think this is one that we've actually worked out already, but if we haven't, so I want this angle, and I don't want this angle because I always measure angles from the positive x. So I either want this one, or let's just say it's that one. You could say that one as well if you wanted to. Okay, so how do we do this? Well, let's use our calculator. Calculator will give us one of them. Remember, when you're finding your angle, just use your calculator. When you know the angle, again, you can just use your calculator. So theta equals inverse sine or arc sine. Inverse sine and arc sine are the same thing. Minus a half. And I think, unless I'm mistaken, that's 30 degrees. Let's use our calculator. So inverse sine of minus a half. So actually I already have minus a half up here from earlier. So inverse sine minus 30 degrees. So it's that one, obviously. So that's equal to theta is equal to minus 30, or what? Well, if that's 30, well, that must be 1. So let's go this way around anyway. You could go this way around if you want to and say, okay, that's minus 180, take away 30, so it's minus 150. Or you can say it's 180 plus 30. So 180 plus 30 is 210. But let's get rid of this. It should be minimized. And remember, sine repeats every 360 degrees, or you could say it repeats every 2 pi, so it's plus 2n pi. Plus 2n pi. Notice I can't write this as one of them. I can't say plus or minus 30. Even if I use other angle, minus 150, they're not the same. So you can't do that with sine. If you call it cos, you can. Okay, example number 7. So these are your answers. Theta is equal to this, or theta is equal to this. So we have 4 possible answers for this question. Example number 7. Find the general solution in radians to the equation 2 cos squared theta plus 3 cos theta equals 2. Again, this is really tricky. It's different from any of those that you've done before. Well, what does this look like? The last one looked like something is equal to 0, so we factorized. This one was just the first one was just rearranging. This one when we had to factorize. And each of these are using a different technique. This one is a quadratic in cos. So let's make it equal to 0 because we like quadratics equal to 0. So we've got 2 cos squared. Remember, cos squared theta, when written like this, just means cos theta times cos theta. plus 3 cos theta minus 2 equals 0. Now treat cos theta. Imagine this was just 2x squared. In fact, maybe if it'll help, I'll write it like this. 2x squared plus 3x minus 2 equals 0. Well, your x is your cos. Now, hopefully this factorizes. Let's try. Maybe if this one doesn't factorize, we'll have to do either completing the square or quadratic formula, but that would make this question very tricky. So 2x, x, numbers that multiply to give you minus 2, well, there are only two possibilities, minus 1 and 2, or minus 2 and 1. And we want to get positive 3, so we want positive 4x. So plus 2 here, minus 1 here. So it factorizes. So this was the x. So what does actually this one actually go to? Well, this one gives me 2 cos theta minus 1, because that's what your x was, and cos theta plus 2 equal to 0. Now we do what we did last time. We've got two things multiplied together to give you 0. So either this is 0 or either that is 0. So we solve that. So at this point, pause and try this yourself. Okay, so let's have a look at this. So we're solving 2 cos theta minus 1 equals 0, and cos theta plus 2 equals 0. We'll do each of these separately. So this is the same as cos theta equals minus a half. And I think, in fact, we've already solved this once. So theta, just use your calculator, inverse cos of minus a half. Well, I think, what do I know? I know cos of 60 is a half. So this is 180 minus 60, which is 120. And also from our diagram, we will see, if you remember, in fact, this is one we've already done. For minus a half, 120 will give me, by the way, you can just use your calculator, just use inverse cos, that'll give you 120. And minus 120 will also give it. So it's plus or minus 120. What are we doing it? Oh, we're doing it in radians, so apologies, it's in radians. So 120 degrees in radians, what is that? Well, that's a 60, which is a pi over 3. So 120 is 2 pi over 3. Again, your calculator, and just to confirm actually, this is what you do in your calculator. So first you put it in radian mode, so shift, setup, and then, well, my one is a little bit different. This is the radians, and then do shift inverse cos of minus, well, 0.5 actually, instead of 1, it's less to type, is 2/3 pi. So this one is minus 2/3 pi, and we're doing it in radians. So what are we adding? So it's plus 2n pi. Those are two of my answers. Let's do my other two answers. This one, so we're solving cos theta equals minus 2. Well, is this ever possible? Can we ever get cos theta equals 2? Well, just think about it. My circle, well, that looks wrong. That's not a circle. But my circle is cos theta is my x. Well, what's my biggest value of x? 1. So the smallest value of x, minus 1. So this is impossible. See, this doesn't work. This doesn't happen. So we can't solve this. This has no solutions. So what are your answers? Doesn't mean that you've done anything wrong. So this can't be equal to 0. So this must be equal to 0. So these are your two answers. That's it. Done. Okay? So this one was a quadratic. So each of these is using different techniques. So the only way you'll get comfortable with these is if you do a lot. Now I'd say things like these last two, they may turn up in FP1. They're the harder kind. So whereas this one, example 5, this is a standard. This is one you need to be able to do at least. These ones, you should really, all you see is just there's a certain technique you factorize. It's just a quadratic. So these don't actually require that much extra work. So once you've done that, you know to do the rest. So it's all about recognizing it. Notice we had to make it equal to 0 first. So we don't solve things quadratics when it's not equal to 0. Okay, and I think there are two left. So example 9 and 10. 8. Find the general solution in degrees to the equation sine theta minus 2 cos theta equals 1. Okay, so have a think about how you do this, because this one I've got a sine there and I've got a cos there. I want to give you a clue. You have to divide. This one you have to divide by something, and we're using something that we've seen today in terms of formula. Have a think about that. Okay, so what we're going to do here is I have two different things. I don't like the fact that they're different. So I'm going to divide everything by cos theta. And 0 divided by cos theta doesn't matter, still 0. Okay, well, what's the point of doing that? Well, what's sine divided by cos? That's tan. So I've got tan theta minus, well, the causes here cancel each other out. So tan theta minus 2 equals 0. And now it's really easy. So that one was really hard, though, seeing that trick. And in fact, I'm not certain that, well, I probably would have seen it eventually, but I wouldn't have got it as quickly as I did here. I looked at it beforehand. And once you see it, of course, it's obvious. So in an exam situation, you might not do it. Again, you practice a lot, and when you come to the exam, you'll be more likely to see it. Okay, let's solve this. So we're solving tan theta equals 2. Tan theta, by the way, can be equal to 2, because if you think about your tan graph, tan can take any possible value. Now we're just going to use our calculator. So are we doing it in degrees and radians? We're doing it in degrees. So if you calculate, my calculator is in radians, so I need to change it, put it in degrees again. Just do inverse tan of 2. That's degrees. We want it in degrees. Inverse tan of 2 is 63.43. And when you're doing tan, you only need one answer. So tan theta equals 2. And that gives me, then I do theta equals inverse tan of 2, which is equal to, what was it? I think 63.1, 63.4 degrees. But it's a general solution. So this is just one solution. I want all possible solutions. And remember, if you remember, as I said before, tan, you don't need the other one. It's just to find all the other ones. You just there to there, it's a gap of 180. There to there, it's a gap of 180. So all you need to do is just plus, say, plus, and by the way, sorry, I'm not going to get rid of that. Degrees, don't like having degrees in there. So plus, although you 180, and because you just add multiples of 180 degrees. That's it. So this one wasn't, once you got to here, it's not so hard. So actually, that's true for every one of these. So once you've done a little bit, you see, well, the first one wasn't bad. Well, these ones, once you've done the first trick, it's not a trick, but it's the first technique. But now that you've seen it, you should be able to do it yourself if that situation comes up. It's not so bad. Right, final example. Example 9. Sine squared plus sine x equals cos squared x. This is one you can't do unless you know, there's a certain thing you need to know from, I think, C3. But you, as people who are doing FP1, you actually need to know this before going to this. So what are we using so far? There's only really 2 trig identities that you need to know for FP1. One of them we've already used, so tan theta. That's just tan is equal to sine theta over cos theta. And the other one is sine squared theta plus cos squared theta equals 1. Now, I don't know if this is in the formula book or not. It may not be, because this is a standard result. This is one that's very common. This is actually, essentially, this is just Pythagoras. It's just another form of Pythagoras. This is a Pythagoras on the unit circle. If you just actually, it's quite simple to prove. Just go back to our unit circle. Where's the last time we had a circle? There. I ignored this bit here. So what do I say? I said your x is your sine theta, right? Your x is your cos theta. That's cos theta. Your y is your sine theta. This is radius 1. This is a right angle triangle. So what can I say? Well, I can say sine squared plus cos squared equals 1. Doesn't matter what your theta is. Okay, so I've actually proven to you this now. So you've got a little bit of a head start in FC3, I guess. So what's the point of this? Well, I don't like it when I've got sine squared, sine, and cos. Now you may be tempted to say, oh, why don't I divide all of these by cos squared so I'll get some tans? Yeah, if you did sine squared over tan, cos squared, you get a tan squared here. You get a 1 here. But this one will be a sine over cos squared. There's nothing we can do with that. Well, that's sine over cos, that's tan sec. And there are things you can kind of do with that, but you don't want to deal with that. And this makes it incredibly difficult. So what this lets us do, because of this, we can change a sine squared into a cos squared and a cos squared into a sine squared. Well, we've got sine here and we've got sine here. So if this was a sine, that would be brilliant. So what do we do? Well, cos squared, this rearranges to cos squared theta is equal to 1 minus sine squared theta. You don't need to remember this form. This is just a rearrangement of that. This is something, you just remember that this is something you can do. So this equation, sine squared x plus sine x equals cos squared x, becomes sine squared x plus sine x. Now don't let the x confuse you. This is not like our x in our, this x is still our angle. So you could call this theta is equal to, and I use theta here. They're just using x for your angle. It's not your x on your x-axis when we do our unit circle. Do not think. This is just a theta. Is equal to what? Well, cos squared is 1 minus sine squared. So it's 1 minus. Now I'm not going to use theta because they're using x's here. So it's 1 minus sine squared x. Let's rearrange this. So this gives me now you should be thinking a quadratic, so sine squared, or you add sine squared to both sides, so you get 2 sine squared x plus sine x minus 1 equals 0. It's just like that. Yeah, that's fine. Can we factorize this? Hopefully we can. So say 2 sine x. And to get a minus 1, it has to be a 1 times minus 1. Well, I want 1 lot of sine x. So I need 2 lots minus 1 lot of this. So I'll put 1 here and a minus 1 here. And you can factorize it out and you'll see it is the same. This is 2 sine squared plus 2 sine x minus sine x, which is just 1 sine x minus 1 equals 0. Okay, I'm going a little bit wonky here as well. Let's straighten it up a little bit. Okay, so I need to solve this is equal to 0 and this is equal to 0. So let's just deal with this first. So 2 sine x minus 1 equals 0. So that's the same as sine x. That's the same as sine x equals a half. Do inverse sine of a half. That gives me x is equal to inverse sine of a half. That gives me, well, we're doing in degrees, no, in radians. So if you did it in degrees, it'll be 30 degrees, which is pi over 6. Notice I know these off the top of my head because we did it earlier in the previous video. It does save a little bit of time. Again, it's pi over 6. And of course, what we're going to do is not just that. We add so any lots of 2n pi or 360 degrees, but we're doing radians, so it's 2n pi. So that's one of them. So I've done, but it wasn't just. Remember, I only used one of my answers. I need my other answer for this. By the way, at the end of this, I should have 4 answers. I should have 4 answers. So that was sine x equals a half. Where sine, remember, sine is your vertical. So I'm going to say sine x equals y. So ignore that. Imagine it was theta. We're trying to find the angles which give me a half here. Well, this one is your pi over 6. So what's this one? Well, this one, if that's pi over 6, using symmetry, by the way, that's a half. Remember, sine is vertical, cos is horizontal. So this one is clearly 5 pi over 6 because the whole thing, 180 is pi. You take away pi over 6, you get 5 pi over 6. So my other answer for x here is 5 pi over 6 plus 2n pi. By the way, sometimes you might not in this case, but sometimes let's say you've got an angle there and there. Sometimes if in the question, if they say between 0 and 2 pi or 0 and 360 degrees, you have to make them both positive. So you can't do, and as before, they'll specify in the question. So in these cos question, for example, I use the positive and the negative angle. If they said, for example, instead between 0 and 2 pi, you have to make them both positive. So one will be 2 pi over 3, and then just do the positive one for the other one as well. So this time, though, there's no specific. They don't specify. If they did, and they wouldn't bother anyway, because they're not going to go, they're not going to say between 0 and pi over 2, and then 0 and minus 3 pi over 2. That's it. That nobody ever does that. So these are my 2 answers for this one. Now I need to solve this. So this is solving sine x plus 1 equals 0. So that means sine x equals minus 1. X is equal to inverse sine. Notice these are x's because they use x in the question. Don't confuse this with the x's here. This is just my angle. Just think about this. X is your angle. Again, this is your theta. And I've said it maybe 3 or 4 times right now. So x is equal to inverse sine of minus 1. And this is one that we can just look at it. When do you get, so remember, sine is your vertical. So when do you get minus 1? Well, there's only one angle that gives you minus 1. It's 270 degrees or 3 pi over 2, or you can go negative because they didn't say we have to use a positive or negative. Negative will be minus pi over 2 because minus 1 here. So this is minus pi over 2. And remember, we had to add 2n pi because it's sine. Done. Okay, so that's it for trigonometry. I know it's 2 40-minute videos, quite a lot. Hopefully this helped. If it didn't, well, you can ask me. We'll cover some more in class. I think you can ask me if you're still unsure about the sign, about what this new circle method. There are videos online. It is, I think hopefully you find out. It is actually much easier to, well, once you get it, understand it, it's much more convenient than drawing sine graphs and cos graphs and things like that. Okay, so that's it for this video. try some exam questions right now. Okay, so go away. Maybe not now, it's 40 minutes, quite long, but soon try some exam questions on trigonometry. Try the questions on integral. Also on integral, there will be alternate methods of doing the same kind of thing. Okay, though the first steps will be the same. The integral website, they do this bit. They don't do it with the circle. They do it slightly differently.